Hi guys. So we're going to try this out, doing the virtual learning thing. A number of you have not gotten back with me about whether or not you have access to these. That would be good for me to know um, moving forward. So if you could please get in contact with me via email and let me know whether or not these lessons are accessible to you, that would be really helpful. Um, yeah, so do that. Uh, So let's jump into this. Last Friday, last time we met, we talked about the idea of resonance structures. And resonance structures, if you will recall, are molecules which vary in terms of their arrangement of electrons. Right? And I gave you a number of practice problems, and we showed how we can move electrons using arrows to represent that change, and how we can combine resonance structures to draw what we call hybrids, right, which are probably closer in reality to the actual structures than any given resonance structure. And we talked about major and minor contributors to those hybrids. But today what we want to talk about is something slightly different. We want to talk about what are called isomers. Specifically, constitutional isomers. Okay. So isomers are molecules which have the same formula but vary in their arrangement. So let's look at an example. C3H8O. Okay. We can arrange this molecule in a number of potential ways. We could arrange it such that all three carbons are in a straight line, okay, or a chain. And at the end of that, we have oxygen attached to the last hydrogen. Now, some of you may recognize that this particular molecule is going to have certain properties. When you have hydrogen bound to oxygen, you have the potential for hydrogen bonding. And so, relative to other intermolecular forces, the attractions between the molecules of this particular substance are going to be fairly strong. Okay? Which means it's going to have things like a higher boiling point, a higher melting point. Alternatively, we could use this same exact formula, C3H8O, and we could draw this with a slightly different arrangement. We could actually break up that carbon chain, putting oxygen in the middle. So same exact formula as we were dealing with before, but now because we don't have hydrogen attached to the oxygen, we get very different properties. This particular compound is going to have a lower boiling point, doesn't experience nearly the strength of the intermolecular forces that would be experienced by the first compound that we discussed. Okay, so again, same formula, but a different arrangement. Okay, and because of the different arrangement, we have very different chemical properties. So that's really the gist of this lesson. I'm going to post some practice problems. All I want you to do right now is take a look at the formulas that I give you and draw some potential isomers, some different arrangements of those atoms that still satisfy what we understand to be true about Lewis structures. Okay, and we'll come back to resonance a little bit later. I'm going to add to this lesson. We're going to talk about one of the ways that we can identify potential isomers a little bit quicker than just trying to put pieces together. But I'm going to give you a couple days to look at this. So I'm thinking I'm going to post again on Friday. So check out that lesson when we get there. We're going to talk about what's called degrees of unsaturation. But this should be enough to get you started for a couple of days, okay? If you need anything, guys, please stay in touch. I'm here. I'm available via email, so send me an email. Let me know what's going on, if there's something I can do for you. I know this situation is kind of chaotic and crazy, but I hope that you're doing okay with it. And we'll get through this. It'll be all right. So stay safe, guys. Stay healthy, and I'll talk to you again soon.